Good morning, everyone. My name's Aman and I'm the GCSE Chemistry tutor for the MyTutor online school. Today's session, we'll be looking at positive and negative ions. So carrying on from last week when we looked at purity and the tests for gases. I hope you all had a lovely weekend. And as usual, if you have any questions at all during this session, please pop them into the chat box or the Q&A function. This session will last for 1 hour, so from 9:45 until 10:45. We won't be doing exam questions today because there's quite a lot of content that I want to cover, but we'll be doing lots of exam questions tomorrow as a consolidation of this topic, and we do have a quiz at the end of the session. So if you haven't met me before, as I said, my name's Aman and I study medicine at King's College London, and I've done plenty of lessons with MyTutor. So today's learning objectives, we need to know the flame test colours for positive ions. We need to deduce the metal ions present in an unknown solution by reacting with sodium hydroxide. So again, that's to do with positive ions. And then for negative ions, we need to know the tests for carbonates, sulfates, and halides. So as I said, it's quite a lot of content, but we'll go through it slowly. And I also find that the main problem with this topic is that it's quite a lot of things that we need to memorize. So I'll try and help you with some tips that helped me when I was learning this when I was at school. Often it's just a lot of perseverance with it and doing exam questions. Someone's asking me what's a halide. It's a very good question. A halide's just a fancy term for a halogen. So it's just a fancy term for a halogen. Okay, so let's do a quick recap of what we covered last week on Thursday. So the first question says that a student tests the boiling point of a sample of phosphorus. It melts at 45 degrees. According to a data book, the melting point of phosphorus is 45 degrees. Is this sample of is this sample of phosphorus pure or impure? Sorry, that should say phosphorus. So is it pure or impure? So just wait for a couple of people to answer that. So great. So I've had a couple of answers so far and everyone is right. Yep, so it's pure. Okay, so now that we know that that sample is pure, the second question is asking us how can we deduce whether a sample is impure? So if we know the first one's pure, what makes an impure sample? So there are 3 reasons for what makes an impure sample. So try and be specific when you give me answers to that. So people are saying different boiling and melting points. Do you remember exactly what happens to the boiling and melting points? So there was a specific kind of trend in them. Okay, so people are saying, first of all, that it will melt or boil over a range of temperatures, and that is correct. So that's one of the points. So remember I said there are 3. So it will melt or boil over a range of temperatures. And the second thing that we can say is that the melting point will tend to be decreased. So melting point will decrease and the boiling point will tend to increase. So the trend with impure substances is that the melting point decreases and the boiling point increases. And then as I said, the other point that we need to know is that they will tend to melt or boil over a range of temperatures. So for example, if we're thinking about impure phosphorus, we might expect it to melt at about 38 to 43 degrees if it was an impure sample. So you can see that that is lower. So the melting point is lower than the pure sample of 45 degrees and it melts over a range of temperatures. So well done to everyone that gave me answers like that. So the third question, so relating to chromatography, how do we calculate the RF? How do we calculate the RF? Okay, so I've had 1 answer so far, so I'll just wait for a few more answers. How do we calculate the RF? So remember chromatography, it's one of the only calculations that we do. Okay, great. So the answer is that it's the distance travelled by the blot divided by the distance travelled by the solvent. So if you remember on chromatography, we've got our chromatography paper here. It would then be in a beaker, let's say, of water. We would then have our line drawn in pencil, not ink, above the water. And remember then we would have a dot on that line for our ink. Let's just put that there. Then that's going to move up the paper and so is the water. So the water in this beaker will then move up. The water will move up to a certain point, which we then call the solvent front. So let's assume it moves up to here. So we call this the solvent front, which is how far the solvent moves up. And then how far the blot moves up that distance, let's imagine it goes to here. So then to work out the RF value, we do how far it moved up. So the dot divided by how far the solvent front moved up. So the distance the blot moved up divided by the distance of the solvent front. So well done to people that gave me the answer to that. Okay, final recap question. What is the test for hydrogen gas? What is the test for hydrogen gas? So we looked at 4 gases last week. We looked at oxygen, hydrogen, chlorine, and carbon dioxide. Good, so we've got squeaky pop test. And the reason I put this question is just because I want to reiterate the difference between oxygen and hydrogen. So remember oxygen, that will tend to relight a glowing splint. So it's glowing for oxygen, and it will relight a glowing splint. But for hydrogen, we say it's a lighted splint. So for hydrogen, it's a lighted splint, and that lighted splint will create a squeaky pop in a test tube of hydrogen gas. So it's really important that we can differentiate between them. So glowing for oxygen, and all that means is if you have a lit splint, you blow it out so that you've got red embers at the end, and that's called a glowing splint, whereas a lighted splint, you'd be able to see the little flame at the end of the splint. Excellent, well done everyone. Okay, so let's move on to today's topic then. So we're starting with flame tests. So positive ions do flame tests. So we've got a little fill in the gap exercise on how we do a flame test. So what do we dip? So we dip a clean something into a sample of the compound being tested. And I'm going to show a video on this in a few moments so that we can understand it in a bit more detail. But does anyone know, has anyone done it at school? What do we dip into the sample being tested? So we're testing for a positive ion, and it's a flame test. So what do we dip? What's the special piece of equipment called? Yep, an inoculating loop or a wire loop. So we'll call it a wire loop. So we dip a wire loop into a sample of the compound being tested. So let's assume we're testing lithium. So we would get our wire loop, and it would have to be clean, and we would dip it into lithium. To make it clean, we dip it in acid first. So the acid will clean that loop, and then we dip it in the lithium. Okay, so then we put the watt in the watt flame of the watt. So I'll give you a clue. This one here is exactly the same as what we've just written up here. So this is, we put the loop, so I'll just put loop here for you, in the watt flame of the watt. So what tends to have a flame? When we're doing our experiments, what tends to have a flame? Good, so we put it into the Bunsen burner. Okay, so this is these words here, so Bunsen burner. Okay, does anyone remember then what flame of the Bunsen burner we do a flame test in? Yep, a roaring flame, but the word that I'm looking for is blue. Yep, so it's a blue flame. So remember, you can open the vent on a Bunsen burner to make it a blue flame. And the reason it's blue is because complete oxidation is happening. So when you open the vent, we're allowing oxygen in. So we're essentially burning that flame in complete oxygen. So it makes a blue flame, and it's roaring. It has lots of energy. Whereas when that vent is closed, there's not much oxygen there. So we get a yellowy, more sooty flame. And so that's the difference between the two flames. Okay, use the watt of the flame to decide the metal ion. So we're trying to tell if lithium is in our sample. So how would we tell from the color? Excellent, yep. So we're looking for the color of the flame to decide the metal ion. Excellent, so just to go over that again, we're going to take a metal loop or a wire loop. We're going to put it into our sample. So I said lithium. We're then going to put that loop into the blue flame of a Bunsen burner. So we hold it in that blue flame, and then hopefully it will light up with a color, and that color tells us which ion is present. Excellent. So on the screen now, you can see the colors of each of the metal ions, and the 6 that you need to know are lithium, which gives a bright red color, sodium, which is yellow, potassium, which is lilac, calcium is an orange red color, copper is more of a sea green, it's like a bluey green color, and barium is more of a yellowy green. So I'm going to show you a video so that we can see the colors of all of these. And the best way that I found to remember these is actually to do the experiment. Now, obviously that's a bit difficult if we're not at school. So the second best thing is to watch videos because it can be quite tedious and difficult to remember all of these colors. So I think it's important that we can at least relate it to something. So I either did the experiment at school or watched the videos to help me to try and remember it. And often you just, when you've watched the video a couple of times, you'll remember the colours. And also in exam questions, the typical questions will say, for example, we've dipped a sample into a flame and we get a red flame, and then you know that has to be lithium. So the exam questions tend to be quite simple. It's just about identifying which metal ion is there. So let's watch the video. So we'll start off with lithium. So there's our blue burning, and there you can see that bright red color. That's lithium. That's lithium in there. So that's a bright red color of lithium. Okay. So the next one we'll test then is sodium. So we're expecting a yellow color, and there you go. You can see the bright yellow for sodium. Okay. The next one we'll test then will be potassium. So we're expecting a purple color. And there we go there. So you kind of see that lilac-y purple color. The next one we'll test is calcium, and we are expecting an orangey red color. So there you go. It's quite a bright red there. It's the orangey red of calcium. Then we will test copper. So copper, we're expecting a, actually first we'll do barium. Sorry, first comes barium. So we're expecting a yellow-green. So there you go, that's the yellow-green of barium. And then finally, if we test copper, we're expecting a blue-green. I like this one, I think it's a pretty color. So there you go, that's the blue-green of copper. Okay, so you can see all the colors there. I will send that link into the chat so that you can all have a look at that video in your own time. So I've sent that to all of you in the chat box. So if you do want to watch it again, you can have a look at all the colors. I think it also includes strontium. You don't need to know about strontium. So you don't need to watch strontium's flame. Okay, someone's asked me to go back to the previous slide. Yep, so there's the previous slide. That was about how we did the flame test. So hopefully you saw she had a wire loop. She put the sample onto that wire loop and then put it into the blue flame of the Bunsen burner. And then we looked at the color of the flame produced. Any questions on that at all? So that's our first test for positive ions that we need to know about. If you've got any questions, just pop them into the chat box or the Q&A. Okay, so the next test that we need to know about for positive ions is the reactions with sodium hydroxide. So we've got the flame tests, and then we've got the reactions with sodium hydroxide. And I'm going to go through this slowly because it's quite a big table and there's quite a lot going on here. So there are 6 or 7 elements that you need to know about. And the reason I say 6 or 7 is because it ranges for the different exam boards, and I'll tell you what the differences are in just a second. So for AQA and EdXL, you do not need to know about zinc. For OCR, you do not need to know about aluminium. So if you're doing the OCR exam board, you do not need to know about aluminium. If you're doing the AQA or EdXL exam board, you do not need to know about zinc. Okay, so that's the first difference between the exam boards, and then all of the rest is exactly the same. So we'll go through each of them in turn. So if we have a sample of aluminium, first of all, we know that there's no flame test color for aluminium, so we can't do a flame test to test for aluminium. So how do we test for it? Well, we add sodium hydroxide. And when we add sodium hydroxide to aluminium ions, we get a white precipitate. And precipitate just is a fancy word for solid. So we get a white solid. And then what we can do is we can add more sodium hydroxide or excess sodium hydroxide. And what will happen is that the aluminium will dissolve, or that white precipitate will dissolve. So when we add a little bit of sodium hydroxide, we get a white solid. When we add lots of sodium hydroxide, it will dissolve. So that's aluminium. And if we have a look at what's actually happening, when we add aluminium, we're then adding it to hydroxide ions. And we're producing aluminium hydroxide. Now, aluminium has a 3+ charge, and aluminium hydroxide will then be AlOH3, like so. AlOH3, because remember we swapped the charges. So the method I taught you a couple of weeks ago is that Al forms a 3+ charge, hydroxide is a negative charge. So when we form the compound, they swap the charges. So it becomes Al1 because there's a negative charge, but it's just one negative. And then OH will take the 3. And the other way you can think about it is the aluminium has 3 less electrons, and hydroxide has 1 more electron. So if they're going to share electrons, we need 3 hydroxides to be shared with 1 aluminium for that bonding to take place. Okay, so that's aluminium hydroxide. Calcium will react with sodium hydroxide to form a white solid. And if we put excess sodium hydroxide in there, we will continue having that white solid. So it does not dissolve. But we also know that calcium has a flame test. So what that's really important for is that if you have an exam question asking you about calcium and magnesium, the way to tell between them is that the flame test color for calcium is orange-red, where magnesium does not have a flame test color. So we can tell between calcium and magnesium by doing a flame test, because they both produce a white precipitate or a white solid with sodium hydroxide. And when we do excess sodium hydroxide, they will continue to have that white solid. They will not dissolve. Zinc is exactly the same as aluminium, pretty much, apart from it doesn't have a flame test. So it will produce a white solid with sodium hydroxide, and it dissolves with excess. So another common exam question will be to ask you about something like calcium and zinc, or calcium and aluminium, depending on which exam board you're doing. And if they ask you about it and one dissolves, you know the one that dissolves has to be zinc or aluminium, whereas the one that doesn't dissolve in excess sodium hydroxide will be the calcium or the magnesium. So that's the difference between these four, and that's the typical exam questions they tend to ask you. So they'll ask you about the difference between calcium and magnesium, or the difference between one of these two and aluminium, or one of these two and zinc, depending on which exam board you're doing. So just remember, OCR, need to know about zinc. Edexcel and AQA, need to know about aluminium. Okay, the final three are a little bit easier to remember because they formed colored precipitates with sodium hydroxide. So if we start with copper, we know that it forms a blue-green flame test. So it's nice and easy then to remember that when we react it with sodium hydroxide, it forms a blue solid because its flame test is also bluey. So we can say that copper forms a blue solid with sodium hydroxide, and when you put excess sodium hydroxide, it will not dissolve. Someone's asking, do Edexcel and AQA do most of the same topics? Yes, all of the exam boards do pretty much the same topics. Why is it only positive ions? Because these are the tests for positive ions. So metals will react with sodium hydroxide. The non-metal ions we will go through in a bit. No, so that is the correct way. So OCR need to know about zinc, AQA and Edexcel need to know about aluminium. Okay, so copper, I said, forms a blue solid and has a blue-green flame test. Do you remember that transition metals tend to form different ions? So they don't just form for example, a 2+ ion, they also can form a 3+ ion, and that is to do with their electron shells. Again, you'll learn about this at A level, which I think I said to you guys when we did transition metals a couple of weeks ago. So iron is one of the transition metals that we need to know about for reacting with sodium hydroxide. And the key thing is that there's two ions of iron, and that is the iron 2+, so Fe2+, and Fe3+. So Fe2+, when we react that with sodium hydroxide, will produce a green precipitate, and that will slowly turn brown if we leave it over time. It doesn't have a flame test, and it will not react with excess sodium hydroxide. Iron 3 will produce a reddish brown precipitate. Again, it doesn't have a flame test and will not react with excess sodium hydroxide. So the key things we need to know about then are these 3 or 4 elements, depending on which exam board you're doing. So aluminium, calcium, magnesium, and zinc. And then the 3 copper, iron 2, and iron 3. And hopefully you can see the differences between them. I'm going to show you a diagram that I drew over the weekend that helped me to remember these positive ions. And I think I did a similar one when I was revising for my GCSEs. So if we have an unknown metal ion, so this is a summary diagram of what we've just covered with the positive ions. So if we have an unknown metal ion, so an unknown positive ion, we can either do a flame test, and the flame test will come up with these colors. So if it's lithium, it will be red. If it's sodium, it will be yellow. Potassium will be purple. Calcium will be an orange-red. Copper will be a blue-green, and barium will be a yellow-green. If the flame test doesn't really work, then we can add sodium hydroxide. And if we get a blue precipitate with sodium hydroxide, we know we have copper. It's copper 2+ ions present. If we get a brown precipitate, then we have iron 3 present. And if we have a green precipitate, then we have iron 2 present. If we add sodium hydroxide and get a white precipitate, then what we need to do is add excess sodium hydroxide. So we'll add a little bit first, and we will probably get a white precipitate if we don't get one of these 3 colors. Then we can add excess sodium hydroxide, and one of 2 things will happen. the precipitate may dissolve, in which case it's either zinc or aluminium. And remember I said that you only need to know about one depending on your exam board. If it doesn't dissolve, then it's either calcium or magnesium. And remember I said to distinguish between these two, we do a flame test where magnesium does not have a flame color, but calcium will be orange or red. So that's a summary diagram of the positive ions. Does anyone have any questions of that? As I said, this helps me to understand it because it kind of puts it all on one picture. If it doesn't make sense to you, then obviously you can find some other way of doing it. But I always find kind of these flowchart diagrams do help. Someone's asking, do you always have to do a flame test? No, you can just straight away add sodium hydroxide. But obviously if you don't get one of these three things, then you know it's not any of these ions or any of these ions, and it might be wise to do a flame test. Usually you do both though. So often in school, you'll end up with 3 samples and you don't know what they are. So you have to do these tests on all 3 samples and you'll figure out which one it is. Someone's asking me to go back to the previous slide. So I've just come back to the table here. So if you have any questions about this table, then feel free to ask me. But that's kind of all the content you need to know about positive ions. So it's about the flame test colors and what happens with sodium hydroxide. And as I said, if you think about it in the 2 groups, so you've got the groups that produce a white precipitate and the group that then produce the colored precipitates. Hopefully that will make the learning a bit easier. And also creating a diagram or something just to put it all on one page can also be helpful. Great, okay, so let's then move on to the negative ions. So remember I said that there are 3 ions we need to know about: the carbonates, the sulfates, and the halides. So we'll start with the carbonates because I think these ones, actually, let me just show you this picture. So this is the picture for the 3 positive ions. So remember I said copper produces a blue precipitate. So this is copper 2+. Iron 3 produces a brown precipitate, and iron 2 produces a murky green precipitate. So remember on the table, if I just go back, so copper 2 is a blue precipitate, iron 2 is a greeny, it's a murky green, and iron 3 is a reddish brown. So they're the colours there. If you've not done it at school, then you can see those. Yep, I can go back to the diagram. Someone's asking me to go back to the diagram. I'm not sure if I can send pictures in the chat because it might be easy for me to send that to you, but I don't think I can. You can either take a screenshot of it, or it will be on YouTube after the session, so you can try and take a photo of it. Yeah, if you like the diagram. As I said, it's one way of thinking about the positive ion tests that I found useful. Okay, so let's move on to the negative ions then, if there are no more questions. Someone's asking, will the biology tuition on last Friday be on YouTube today? I think they will try and put the YouTube sessions up soon. I don't think my YouTube videos from last week are up yet either, but I'm sure they'll be up soon. Okay, so let's move on to the negative ions. So we'll start with carbonates. Remember there are 3 ions we need to look at: carbonates, halides, and sulfates. So we'll start with carbonates. So carbonates are detected using a dilute acid, and it is usually hydrochloric acid that we use. And what we tend to do is we add the metal carbonate to the dilute hydrochloric acid. And what we will see happens is that we will get a metal chloride produced, carbon dioxide, and water. And what we test for then is the carbon dioxide. So hopefully you remember from last week, we looked at the test for carbon dioxide, and that is that the bubbles of carbon dioxide, when they're given off, we put them or bubble them through lime water, which will turn cloudy. So the test for a carbonate ion is essentially if carbon dioxide is given off. And when we see a gas produced, we then have to test whether it's carbon dioxide. So if a question asks you about the test for carbonate, the test for carbonate is that we add dilute acid, and then we test the gas given off, and if it's carbon dioxide, then we know we have a carbonate ion present. So this is the general form, the ionic formula for what's equation for what's happening. So we have a carbonate ion reacting with the hydrogen ions. And remember, those hydrogen ions come from the acid. So remember, the ion that makes an acid is the hydrogen ions. And when the carbonate ions react with the hydrogen ions, we get carbon dioxide and water. So that's the ionic equation for what's happening. This is the word equation up here, where we've got the carbonate reacting with dilute hydrochloric acid to produce a metal chloride, carbon dioxide, and water. So we'll do 2 examples. So we've got calcium carbonate reacting with dilute hydrochloric acid. So first of all, what are the 3 products produced when we react calcium carbonate with dilute hydrochloric acid? Use this as your baseline to help you. So what are the 3 products produced when we react calcium carbonate with dilute hydrochloric acid? Does anyone know? Or what are we expecting to be produced? Good, yep, so we're expecting calcium chloride, excellent, carbon dioxide and water, excellent. So we are expecting calcium chloride, carbon dioxide and water. So let's try and write out that whole equation then. So we have calcium carbonate, so calcium is in group 2, so that means it has a Ca2+ charge, and we know carbonate has a 2- charge. So when they react together, it will just be CaCO3 because they've got the same charges, but one's 2+, one's 2-. So that's calcium carbonate. We react with hydrochloric acid, which is just HCl. And then we're going to produce calcium chloride. So remember, calcium's Ca2+. Chlorine is in group 7, so that means it loses it gains 1 electron to produce Cl-. So when they react together, if they swap charges, it will be CaCl2. So CaCl2. And then carbon dioxide and water. So that's the balance, well, it's not balanced yet, but that is the equation for calcium carbonate. And then we can see if it's balanced. So we've got 1 calcium, 1 calcium, 1 carbon there, 1 carbon, 3 oxygens, 2 + 1 is 3, 1 hydrogen, but there's 2 hydrogens, and 1 chlorine, but there's 2 chlorines. So all we need to do is make the HCl2, and then that will make the chlorines 2 and the hydrogens 2, and then everything else is balanced. So that's the balanced equation for calcium carbonate with dilute hydrochloric acid. So any questions about that at all? Okay, so the next example then we have is potassium carbonate and dilute nitric acid. So what are the products this time then? Potassium carbonate and nitric acid. So as I said, they usually use hydrochloric acid, but you can use nitric acid as well. In exam questions, you're more likely to see hydrochloric acid. So what are we likely to see? Good, so not potassium chloride, because remember it's nitric acid this time. So with nitric acid, we're likely to see potassium nitrate. So everyone that said potassium nitrate, excellent. Carbon dioxide and water. Brilliant, so let's write out that equation then. So potassium forms a K+ charge, it's in group 1. Carbonate is CO3, 2-. So when they swap, we're going to have K2, because it's going to take the 2, and the carbonate's just going to take a 1. So K2CO3, so that's potassium carbonate. Nitric acid, does anyone remember the formula for nitric acid? What's the formula for nitric acid? Not NH3, NH3 is ammonia. What's nitric acid? So NH3 is ammonia. You're on the right tracks. Not quite, not NH6, nope. Anyone else got any answers? Nitric acid? Okay, all right, so I've had 1 correct answer then. So it's HNO3, excellent, HNO3. So that's nitric acid there, HNO3. And the reason it's HNO3 is because H, hydrogen, forms a positive charge, +1. Nitrate ions form a negative charge, -1. So when they bind together, it's just 1 hydrogen to 1 nitrate. So HNO3 is nitric acid. It's then going to form potassium nitrate. I've told you that NO3 forms a negative charge like that, and potassium forms a positive charge. So when they bind together, it'll just be 1 potassium to 1 nitrate. So potassium nitrate is KNO3. We've then got our carbon dioxide and our water. So now if we check the balancing of this question, first of all, we can see that there's 2 potassiums, but we've only got 1 potassium. So we know we need to make that a 2. We've got 1 carbon, 1 carbon, 3 oxygens plus 3 is 6. So there's 3 in the nitrate times 2, which gives us 6 plus 3 here. So we've actually got 3 more oxygens there. So to deal with that, we know we need to make this 2 to make our nitrates 2. And then if we have a look at our hydrogens, we now have 2 hydrogens, and we've already dealt with the nitrates, which we've said are doubled on both sides. So that is the balanced equation for potassium carbonate reacting with dilute nitric acid. So as I said, the test for a carbonate is we add a dilute acid, and then we test the gas using lime water, and if the lime water turns cloudy, then we know we've got carbon dioxide produced, and therefore carbonate ions are present. So any questions about that at all? Someone's asking, do we need to know that off by heart? So you do need to know the common acids. So we covered neutralization reactions a couple of weeks ago, and we went through all the common acids. So the main acids you need to know about are hydrochloric acid, sulfuric acid, nitric acid, and ammonia and carbonic acid. It's not called potassium, it's called potassium nitrate. So potassium nitrate is the product. Excellent. Okay, so let's move on to the second negative ion. So halides. So the halides are the second negative ion, and someone asked me earlier, what is a halide? A halide is just a fancy term for a halogen. And there are three halides that we need to know about, and they are bromine, chlorine, and iodine. So bromine, chlorine, and iodine. And what's really important with these is that we can distinguish between them when we react with silver ions. So the test for halides is reacting with silver ions, and when we react silver ions with these, we get a coloured precipitate. So chloride ions will form a white precipitate, bromide ions will form a cream precipitate, and iodide ions will form a yellow precipitate. And that precipitate is silver reacted with the halogen. So in chloride ions, it's silver chloride, which silver forms an Ag plus charge, and chlorine, bromine, and iodine all form a negative charge because they're in group 7, so they gain 1 electron. So when we have silver chloride, it's AgCl. The cream precipitate of bromine is AgBr, silver bromide, and the iodide one is AgI. So they're the three precipitates, and the reason we're getting those precipitates is because we've got silver ions reacting with the halogens. So to do the actual test to get silver ions to react with those halides, first of all, we add acid. And the reason we add acid is to remove any carbonate. So remember, the test for carbonate is to add a dilute acid, and if we get a gas produced that's carbon dioxide, we know we've got a carbonate ion present. So when we're testing for a halide, first of all, we always add an acid just to make sure there's no carbonate ions present. And if there are carbonate ions present, they will react to then produce your chloride if you've added hydrochloric acid, or nitrate if you've added nitric acid, and that will then produce your carbon dioxide and water. And then after we've done the nitric acid test, we then add silver nitrate. And it's the silver nitrate that is the official test of halides. But when you get asked in exam questions for the test for a halide, you must say both. So you must say we add dilute nitric acid followed by silver nitrate. And if they ask you to write the ionic equation for what's happening, you don't need to write the equation for nitric acid. You need to write the equation for silver nitrate, which is this equation here. The silver ion, which is Ag+, reacts with the halide ion. So I've written that as H-, but you would replace that with whichever halide is in the question. So if it was bromine, we would put Br-. If it's chlorine, Cl-, or iodine, I-. And then that will react to produce silver plus the halogen. So it'll be either AgCl, AgBr, or AgI, depending on which halogen you are testing. So before we have a go at writing some of the equations for those reactions, I'll just show you the colours. So how I tend to remember this is it's a bit like a continuation. So on the periodic table, the order is chlorine, bromine, iodine. And then if we have a look at these colours from left to right, this is the white of chlorine. This is cream here. It's between the white and the yellow, so bromine. And then this is iodine. So this is the yellow of iodine. So when you're doing it, if you think about it as a continuation, it might help you to remember it. Someone's saying, I'm a little confused. Do silver ions mean silver nitrate? So good question. So when we add silver nitrate, remember then that silver nitrate will have in it silver ions and nitrate ions. So silver nitrate is just AgNO3. But when we react that with our halide, essentially the nitrate gets displaced by the halide. So you can kind of think about it like a displacement reaction, and so you end up with the silver and the halogen. So good question. Yep, so someone's just said, is the nitrate ion displaced by the halide? Pretty much, yes. Someone's asking me to go back to the slide. Yep. I think you're talking about, oh, not that one, this one. Yep, there you go. So if you think about it as a continuation down the periodic table, so it usually goes fluorine, chlorine, bromine, iodine, but we obviously only need to know about chlorine, bromine, iodine. So if you think about it like that, chlorine starts off white, bromine will then be cream, and then yellow. So think about it as a continuation, slowly getting more and more yellow. And that will hopefully help you remember the colours of those precipitates. Good, any questions about that at all? And then we'll write some equations for those. So really good questions we've had so far. Okay, great. So we know our coloured precipitates. We know we add dilute nitric acid to remove any carbonates. So remember, that is the test for a carbonate, by adding a dilute acid. So that's why we add it, to make sure there's no carbonate present. And if there is carbonate present, we do it to remove the carbonate. And then we add silver nitrate. So let's try and write silver nitrate plus potassium chloride. So what are we expecting to be produced in this reaction? Silver nitrate and potassium chloride. What are we expecting to be produced? So I've not told you the products of what happens. So let's see if we can have some guesses, or you can work it out. So we know one of the products has to be to produce the precipitate. And then the second product is whatever's left. Great, so someone's given me an answer. So they've said silver chloride, excellent. So that's going to produce your precipitate, and silver chloride will be white because it's a chlorine ion that's present. So silver chloride, and then whatever's left is potassium nitrate. Yep, so excellent, someone said potassium nitrate. And the reason we know that is because we've got silver nitrate reacting with potassium chloride. And whenever silver ions react with a halogen, they will produce a coloured precipitate. So we know coloured precipitate has to be silver chloride, and then that leaves nitrate and potassium ions present, and then they react together to produce potassium nitrate. So the two products will be potassium nitrate and silver chloride. So let's write that out then as a balanced equation. So silver nitrate, I've written here, is just AgNO3, and that's because silver forms a positive charge and nitrate forms a negative charge. So when they bond together, it's just one silver for every one nitrate. So AgNO3. It will then react with potassium chloride. Potassium forms a positive charge. Chlorines in group 7 forms a negative charge. So one potassium reacts with one chlorine. To then produce silver chloride, which is just here, AgCl, and our potassium nitrate. Again, potassium forms a positive charge, nitrate a negative charge, so they'll bind together to form KNO3. And then if we have a look at the balancing of that, we've got one silver, one nitrate, one potassium, one chlorine, one chlorine. So that's all balanced. You don't need to balance that. Everything is balanced there. Any questions on that at all? So that's the equation, the silver nitrate and potassium chloride. Okay, great. So let's do silver nitrate and zinc iodide then. So this time, why don't you guys have a go at telling me what the products are, what colour precipitate we're expecting to see, and then we'll write out the balanced equation for it. So someone's already given me that answer, which is great. Does anyone else want to have a go? So silver nitrate and zinc iodide, what will be the products and what colour precipitate are we likely to see? So the person that's already given me the answer, you are correct. Well done. So I'll just wait a few moments for anyone else that wants to answer to have a go. Great, yep, so I've just had another answer come through. You are also correct. Okay. So everyone's saying silver nitrate reacts with zinc iodide to produce zinc, nitrate and silver iodide, and we are expecting a yellow colour. So well done everyone that's given me that answer. We're expecting a yellow colour because we've got iodide ions present and they form a yellow precipitate. So well done. So again, if we're going to write that out, we have our silver nitrate, which is just AgNO3. It's then reacting with zinc iodide. Does anyone know the charge on a zinc ion? It's a transitional metal. Does anyone know the charge on a zinc ion? It's okay if you don't. Good. Yep. So someone said 2+. Exactly. So zinc usually forms a 2+ ion. Well done. You wouldn't be expected to know that. They would give you that in the exam. So yep, well done. So zinc forms a 2+ charge. And remember, iodine is a halogen. It forms a negative charge. So when they react together, that means that there needs to be 2 iodines for every 1 zinc. And remember, they're sharing their electrons or donating their electrons. So for zinc to form its full outer shell, it needs 2 electrons, because at the moment it's got a 2 positive charge. So to form its outer shell, it needs 2 electrons, whereas iodine only needs to lose 1. So that means we need 2 iodines for every 1 zinc. So ZnI2. Excellent. So zinc iodide will then produce your silver iodide, which is your yellow precipitate. So AgI, which is just here. And then your zinc nitrate. So nitrate is NO3-, whereas zinc is 2+. So again, when they react together, we need 2 nitrates for every 1 zinc. And that's because zinc needs 2 electrons, whereas nitrate only has 1 to give. So it's ZnNO3, like so. So we do need to balance this out then. At the moment, we have 1 silver, 1 silver, 1 nitrate, 2 nitrates. So first of all, we need to make this 2 to make it 2 nitrates. And then if we have a look, we've made 2 silvers now. So we need to make sure our silvers balance. And then now we've got 2 silvers, 2 silvers, 2 nitrates, 2 nitrates, 1 zinc, 1 zinc, 2 iodines, 2 iodines. So that's your fully balanced equation for silver nitrate and zinc iodide. Any questions about that at all? You're all doing a really good job of answering my questions today, but if anyone has any questions about that, please put them into the chat box or the Q&A function. Okay, so the final negative ion we need to be able to test for then is a sulfate ion. And essentially when we test for sulfate ions, just like with our halides, we need to add acid first. So we add in dilute hydrochloric acid. And again, it's just like with the halides, we do it to remove any carbonates. So remember, the test for a carbonate is to add dilute acid, and if carbon dioxide is given off, which we test by using lime water, then we know we have a carbonate present. So when we're testing for a sulfate, first of all, we need to make sure we don't have a carbonate. So we add hydrochloric acid. Then the special solution that we add for sulfates is barium chloride. So the special solution for halides was silver nitrate. The special solution for sulfates is barium chloride. And what happens is, if we have a sulfate present, the barium ions in the barium chloride will react with sulfate ions, which is what we're testing for, to form insoluble white barium sulfate. So if we see a white solid produced, then we know we have a sulfate present. And that's because the barium ions in the barium chloride, so barium is 2+, so BaCl2, like so, because chloride is minus, barium is 2+. So we need 2 chloride ions for every 1 barium ion. So BaCl2, the barium ions will react with the sulfate ions to produce barium sulfate. That's what's here. We've got our barium ions reacting with sulfate ions to produce barium sulfate. And if that barium sulfate is produced, it's a solid and we get a white precipitate. Any questions on that? So that one's potentially a little bit easier than the halides, because all you need to remember is then if we react with barium chloride and we get a white precipitate, then a sulfate ion is present. You don't need to remember any colours as such, it's just a white precipitate. Okay, so no questions there. So let's have a go then at trying to figure out what's going to be produced in both of these reactions. So sodium sulfate plus barium chloride. What do we think are the products here? So sodium sulfate plus barium chloride. So you should be able to tell me one. Yep, so someone's saying, is it that a methyl sulfate reacts with barium chloride to produce barium sulfate? Yep, so it will produce barium sulfate and something else. So just like with the halogens, if I go back to the halogens, remember when we reacted silver nitrate with potassium chloride, we got our silver chloride, which is the test basically for a halogen, but what we're left with is the potassium and the nitrate. So just like that, when we're testing for our sulfate ions, we will have our barium sulfate produced here, and then what we're left with is sodium chloride. So everyone that said sodium chloride, well done. So you always have something left over, and that forms the other product. So in this case, it would be barium sulfate plus sodium chloride. So well done to everyone that gave me that. So let's have a go at writing that question out then. So sodium sulfate. So the sulfate ion is SO4 2-. Sodium's in group 1, so it forms Na+. So this time, why don't you guys tell me what is the formula for sodium sulfate? I told you sodium is a positive ion, sulfate is 2 negative. What's the formula for sodium sulfate? Excellent, I've had one answer so far, I'll just wait for a few more. Good, yep. Okay, so because sodium has a positive charge, a 1 positive, and sulfate has a 2 negative, we need 2 sodiums for every 1 sulfate ion, and that's because sulfate has 2 electrons to give, whereas sodium only wants to accept 1. So for sodium to react with sulfate, we need 2 sodiums so that it can accept both of those electrons. So excellent to everyone that said Na2SO4, so that's our sodium sulfate. React it with barium chloride, which I've already written up here, and that's because barium has a 2+ charge, chloride has a -1 charge, so when they react, we get BaCl2. It's then going to produce barium sulfate, so this one's slightly easier because barium's a 2+ charge, sulfate's a 2 negative charge, we just get BaSO4, so we don't have any, we don't need it, the ratio is just 1 to 1. Good, and then we produce sodium chloride. So remember, sodium is Na+, and chloride is Cl-, so again, 1 to 1, because sodium has 1 electron it needs, chlorine has 1 to give, so we just react 1 sodium with every 1 chloride. Okay, so let's see if we need to balance this. Does anyone want to have a go at balancing it and telling me the answer this time? Someone's asking, is sulfate sulfur and oxygen? Yeah, really good question. Sulfate is sulfur and oxygen, and you can see that in the ion. So if we have a look at the sulfate ion just here, you can see it's 1 sulfur to 4 oxygens, and that's the sulfate ion. So really good question there. Good. Okay, so everyone is saying we need 2 NaCl. So let's have a look at that. We've got 2 sodiums. So yes, on the product side, we only have 1, so we need to make that 2. We now have 2 sodiums, 1 sulfate, 1 sulfate, 1 barium, 2 chlorines, 2 chlorines. So excellent, well done. Okay, final one, and then we will do a quiz. You're all doing really well today. I know this is quite content heavy, so very well done. So the final one then is magnesium sulfate and barium chloride. So this time, why don't you all have a go at trying to write out the balanced equation for magnesium sulfate reacting with barium chloride. I'll give you a couple of minutes to do it. And if you need help, I'll talk through it as we're going, but I'll talk slowly so some of you can have a go at writing that out yourselves. So we've got magnesium sulfate reacting with barium chloride. So remember, when we have a sulfate ion present, the test for a sulfate ion is to add that barium chloride after you've added hydrochloric acid. And the products will then tend to form your barium sulfate. So one of the products here will be barium sulfate. And then the other 2 ions that we're left with will form the other product. Yep, so someone's saying help please, so that's fine, I will help you through that. So as I said, barium sulfate is one of the ions. Because we've used up the barium and the sulfate, what's left is magnesium chloride. So the other product is magnesium chloride. So we've got barium sulfate and magnesium chloride produced. Now, to write out that equation, if we start with our magnesium sulfate, magnesium is in group 2, so it forms an Mg 2+ charge, and we know sulfate forms an SO4 2- charge. So hopefully that will help some of you to write magnesium sulfate out. We already know how to write barium chloride, and then I said barium sulfate was one of the products. We've already written barium sulfate out, and the final product was magnesium chloride. So remember, magnesium has a 2+ charge and chlorine has a negative charge, so that should help you to write out the products. Okay, so I've had a few answers, so we'll write it out together. Well done to everyone that's written it out. I think you are mostly all correct. Okay, so magnesium sulfate, Mg2+, SO4 2-, so they are just a 1-to-1 ratio like so. Barium chloride is just BaCl2. It's then going to react to produce barium sulfate, which we've already written out, BaSO4. And then finally our magnesium chloride, but because Mg is a 2+ charge and Cl is a minus, that means we need 2 chloride ions for every 1 magnesium. And the reason for that is that chlorine only has 1 electron to donate, but magnesium needs 2. So that means we need 2 chlorine ions to make sure magnesium gets its full outer shell. So MgCl2. And if we have a look at the balancing of this, 1 magnesium, 1 magnesium, 1 sulfate, 1 sulfate, 1 barium, 1 barium, 2 chlorines, 2 chlorines. So no balancing required, it's already all balanced. Excellent. So everyone that gave me your answers, as I said, you were all mostly correct. So very well done. Okay, so before we do our quiz to finish off today, let's just go back to our learning objectives and make sure everyone's happy. So know the flame test colours for the positive ions. I will show you that again in a second. Deduce the metal ions present in an unknown solution by reacting with sodium hydroxide. So remember, there were 6 ions that had flame tests, and there were 6 ions that would react with sodium hydroxide that you need to know about. Again, I'll show my diagram in a second. And then we've just been through the tests for carbonates, sulfates, and halides. So as a recap, carbonates, we add dilute acid to them. And when we add dilute acid, if we get a gas given off, we test it, the CO2, with lime water. And if the lime water turns cloudy, we know CO2 is being produced and therefore a carbonate was present. When we're testing for sulfates, we add dilute acid, and that's to remove any carbonate. And then after that, we add barium chloride. And when we add the barium chloride, if we get a white precipitate, we know that precipitate is barium sulfate, and therefore we have a sulfate ion produced. So we get a white solid of barium sulfate. And then finally, the halide, we add dilute nitric acid. So usually this one is hydrochloric acid, and this one tends to be nitric acid for halides. Then we add silver nitrate. And if with the silver nitrate we get a coloured precipitate, which will either be white, cream, or yellow, then we know we have either chlorine, bromine, or iodine respectively present. So well done. How is the sulfate being tested? Good question. So when we test for sulfates, what happens is we add the acid, and that's just to make sure there are no carbonates. Then we add barium chloride. And if there is a sulfate present in the sample that we're testing, the barium in the barium chloride will react with that sulfate ion to produce a white solid. If a white solid isn't produced, that means there's no sulfate ions. So very good question. Yep, I will go to slide 4 in just a second. So just as a quick recap of the positive ions, remember we can either do a flame test, and there were 6 ions you needed to know about: lithium, sodium, potassium, calcium, copper, barium, or we add sodium hydroxide and you get blue with copper, brown precipitate with iron 3, and green with iron 2, or you get a white precipitate and then we add excess sodium hydroxide to tell which ion it is. Someone's asking me to go to slide 4, so I'll go to slide 4. So that was just how we do a flame test. And someone's asked me to go to the previous slide, which I think is the slide on sulfates. So I will go back to that. Yep. There we go. Okay, so let's do a quiz then to cover and consolidate everything we've done today. As I said, it's a lot of learning. So if you need to rewatch this session, I would definitely recommend that. It should be up on YouTube either later today or tomorrow. So if you go to menti.com and type in the code 588222, you can join the quiz. It's just 5 questions. And as usual, the faster you answer the question, the more points you get. So I can see one person's joined, which is excellent. So I'll just wait a couple of moments for everyone to join. And if you've got any Q&A questions, please pop them into the chat or the Q&A, whichever function you prefer. I'll just wait for a couple more of you to join. Good, so this is just to consolidate all your learning, because obviously we've done a lot of learning today. So I've got 35 of you in the webinar, so I'll wait a few more, so we've got 17 in the quiz. Okay, I'm gonna wait another 10, 20 seconds and then I'm gonna start it. If you haven't joined yet, you can join halfway through the quiz, but obviously it will affect the number of points you get. So if you're in a competitive mood, then I would recommend joining now. If you can't join the quiz, you should be able to. You don't need to make an account or anything, but if you can't, you can always send me the answers in the chat or the Q&A as we're going through. Okay, let's start it up. Right, the first question, it should be coming up on the screen now. So what color flame does sodium burn with? So what color flame does sodium burn with? So red, yellow, green, or blue. Anyone that's not in the quiz that wants to answer, you can send your answer in the Q&A or the chat. Good, so we've got 5 seconds left. Okay, so the answer is yellow. So sodium will burn with a yellow flame. Excellent. Well done to everyone that remembered that. That's really good going. Well done. Okay, so red is lithium. Blue tends to be copper. You get a blue-green, and the yellow-green will be barium, but also copper. So good. Okay, the next question should be coming up on your screen now. So what color precipitate does iron 2 produce when reacted with sodium hydroxide? So what color precipitate does iron 2 produce when reacted with sodium hydroxide? So is it white, blue, brown, or green? So hopefully you remember when we react with sodium hydroxide, we will either produce a white precipitate, a blue precipitate, brown, or green. So the answer for iron 2 is green. So well done to everyone that put 9, so the 9 people that put green, well done. So white precipitate will tend to be aluminium, magnesium, calcium, and zinc. Blue will be your copper 2 ions. Brown is your iron 3 ions, and iron 2, so that's why you got the 2 here, is green. So well done, everyone. Okay, so the next question should be coming up on the screen now. So which of these is a white precipitate? So we're probably going to get some products. So we've got some products here, and we need to know which of them is a white precipitate. So is it copper hydroxide, potassium iodide, aluminium hydroxide, or sodium bromide? Okay, so the answer is aluminium hydroxide. Well done, everyone. So copper hydroxide forms a blue precipitate. So remember, blue with sodium hydroxide. Potassium iodide will not really have a color. Sodium bromide will not have a color. So the only color which will be white is aluminium hydroxide. But remember, if we add excess hydroxide ion, excess sodium hydroxide, it will dissolve. But yes, it does produce a white precipitate. Well done. Okay, so the next question is here. So what do we add to dilute nitric acid and a halide compound to test for the halide? So you have to type your answer in this time. So what do we add to dilute nitric acid and a halide compound to test for the halide? So what is the solution that we add to the halide to test for that halide? So we add dilute nitric acid and then we add something else afterwards. And that something else we add is the solution that tests for the actual halide. Remember, the nitric acid is used to remove any carbonate, but the solution we add afterwards is what we use to test. So it's silver nitrate. Good. So people that said silver nitrate solution or silver nitrate, well done. So the answer is silver nitrate. Excellent. So it's not carbonate. This one's probably just someone spelt it wrong. But yep, silver ions, that's fine. In the exam, you do need to say silver nitrate though. It's not nitrate chloride, it's silver nitrate. Excellent. Well done, everyone. Okay, so what compound is produced when we have a positive test for sulfate ions? So we've tested for sulfate ions. What's the name of the compound produced? It will be white when we produce it. What's the name of that compound? That's what I'm looking for here. What's the name of that compound that will be white? And when we produce that white compound, we know we have sulfate ions present. So what's the name of that compound? So 5 seconds left. Excellent. So the answer is barium sulfate. Good. So a couple of you said barium sulfate. So it's barium sulfate that we're looking for when we test sulfate ions. So not, so most people have said barium sulfate there. So not barium ions, but barium sulfate. So the barium ions react with the sulfate ions. Excellent. So I think that was the last question. So yeah, we'll get the leaderboard now. Okay, we've got a different winner this time. So A is the winner. So well done. Good job. Excellent. So that pretty much concludes today's session. If you have any questions at all, feel free to ask them now. If not, I'll just let you know the next session is on Wednesday morning, so 9:45 in the morning. We'll be doing a little bit more on this topic. So we're just going to look at flame emission spectroscopy. And then we'll be moving on to our next topic, which is looking at the Earth and analysis of the Earth, so the Earth's resources. So well done, everyone. I hope you enjoyed today's session. It should be up on YouTube soon, and last week's session should also be up soon as well. So take care, have a lovely couple of days, and I will see you on Wednesday. Bye.